Okay, in this video, we're going to be going through everything on the summative review for the on-level section. I'm going to be going through every single problem, talking about how I would do them. I'm going to give alternative examples, submit some answers, and I'll post the key that we make at the end of this on Canvas for you guys. Currently available, what you might want to do as you're going through is rate yourself on each of these skills. There's a page associated, for example, 2A has its own page, right? So there's a page associated with each skill. Go through, find the skills that you would rate yourself less than a 3.5 maybe. And those are the skills that you should be worried about as you work through. So, down here in your notes to self, studying for math. Just remember, you want to rate yourself in the skill. All right? Wow, that's horrible. Rate yourself in the skill. Sorry, the Apple Pencil's still broken, so hopefully it will work better. Rate yourself. That's a good first step. The next thing you probably want to do is make sure you are practicing each problem. So practice through. So try these problems on your own, then see how I do it, right? See if you get the same answer. Guys, if you get the same answer and your strategy works, that's totally fine. I'm never going to be mad at you for getting the right answer. All right. There's also a Delta Math available. Email me if you have questions about getting to Delta Math. I'm going to be looking at my email all weekend. Make sure that you, if you're looking to practice those problems, make those changes for the test on Monday. For on-level kids, it'll be on Monday. That's about it. Without further ado, let's get into it. I'm going to walk through each of these problems pretty quickly. So if you need to slow down the video, make sure you can either slow down the video, speed it up, add captions, whatever you want to do. I'm just going to work through them, show you guys what I'm thinking. So you want to find 1/4 the distance from -8,1 to 4,9 and estimate its location on the grid below. All right, well, -8,1, that's over here. -1, 2, 3, 4, 5, 6, 7, 8. There's 8, and then 1 up. That's our first point. And then over here, we run to 4, 9. 1, 2, 3, 4. Up, there's 4, there's 8, there's 9 right here. So this line is the segment we're actually trying to cross. We're trying to go 1/4 the distance from here to here. Now, a common misconception is to see distance and then immediately think, oh, use distance formula. Just make sure, this is a common mistake, you don't need the distance formula. Don't use the distance formula for a fractional distance problem. This actually requires trig. If you want to do it this way, it requires trig. And we just haven't learned that yet. We will learn trig eventually. Those are like, this is just, don't write this down in your paper. This is just a aside from Mr. Shirley. We will learn cosine, sine, maybe you have heard this before, and tangent. These are called transcendental functions that are used in trigonometry. We don't need them right now. All right, we're going to do it another way. So instead of walking 1/4 across this line straight up, what we might do is walk 1/4 in the x direction. Like maybe, I don't know, somewhere over there is 1/4. I'm just guessing. And then in the y direction. So in blue, we're going to be doing the x direction, and in red, there's the y direction. So over here in blue, here's x. I already know how to walk. We've done this in Unit 1. I already know how to walk on a number line from -8 to 1. There's my x coordinates, right? I'm sorry, not 1, but 4. -8 to 4. The total distance across these guys, we may know it's 12. If you don't know, it's just absolute value of -8 minus 4, which is 12. All right, and I want to walk 1/4 that distance, so I'm going to go 1/4 of 12 from 8. 1/4 of 12 is 3. If you don't know, just plug it in your calculator. You can also just break 12 up into fourths if you wanted to. 3 times plus 3 plus 3 plus 3. And you only need one of those. So we're talking about 3 would be 1/4 of 12. Now I want to move from -8. I want to move towards positive 4 plus 3. That's 1/4 the distance that I just found, plus 3 over, which would be -5. All right? Boom, you're done. That's your x-coordinate right there. Now in red, I'm going to do the y-coordinate the exact same way. I'm going from 1 to 9. So 1 to 9 on the number line, I want to go 1/4 the distance. Well, those guys are 8 apart, right? 9 minus 1 is 8. 1/4 of 8 is, of course, 2. 8 divided by 4 is 2. Oh, sorry, I just slapped the microphone. Then we're going to move from 1 plus 2 towards, excuse me, sorry. I'm starting at 1, moving towards 9. That's plus 2 equals 3. There's my y coordinate, okay? And that's all I need to know. So if I come over here and I find my point, if I start at the origin, I count back 1, 2, 3, 4, 5. That would be, let me do that in blue actually, but that would be my coordinate right here. And then the y direction, same thing, but up 3. 1, 2, 3. So this point, you can see it lies perfectly on our line. Since I'm on the iPad, it lines up perfectly. If you draw it yourself, it may or may not. If you use a ruler, maybe, but that doesn't always happen. And this point right here, the point, -5, comma 3. That is 1/4 the distance from -8, 1 to 4, 9. Make sure you're trying these problems on your own before you see the solution so you know what's going on. All right, but this is the same exact principle. I'm going to do the same exact thing for these two problems down here. There's just no picture now. That doesn't matter. Don't worry. As long as we're still going to do the same thing. So in blue, here's my x-coordinate. -3, 2, 9. So I'm walking from -3 to 9, and I want to go 2/3 the distance. So let's see. Absolute value of -3 minus 9 is equal to 12 again. So we have a 12 again. This time we want 2/3 of 12. 12 is a pretty good number to pick for these. Well, 12 split into thirds. Maybe you don't know immediately. You can just always plug this in your calculator if you want to, but I'm just going to write over here. For me, I like to split 12 into thirds. That'd be 4 plus 4 plus 4. And I want 2 of those thirds. Sorry, I meant to use the... I want 2 of those thirds, so that is a total of 8. All right, so 8 is 2/3 of 12. Beautiful. Now I want to walk -3 towards 9. That's in the positive direction, so I'm going to add 8. 8 is 2/3 the distance from 3 to 9, so I'm going to add in 8. -3 plus 8 equals 11. Yes, 11. And then for the y direction, same exact business. Over here in red, from 6 to 15. Now this picture I'm drawing is just supposed to behave like my number line. This is just showing me where these numbers go in relation to one another. I know that 6 is to the left of 15 on the number line because it's less than 15. So 6 to 15, I know that 6, I could say 15 minus 6 is 9. There's my distance across 2/3 of 9. You may know what it is. If you don't, that's okay. Just break it up. Over here, I'll do it. 9 split into 3 groups is 3 plus 3 plus 3, right? And I want 2 of those groups, which is 6. So 2/3 of 9 is 6. Also, can do it in your calculator. Then 6 plus that distance is another 6. Starting at 6, then moving to the right by 6 to get 12. All right. So now I have my full coordinate that I'll then write over here. So I did this work to find my x coordinate, this work to find my y coordinate. Now I'll combine them over here into an ordered pair, xy, which is my solution, 11, comma 12. No picture required. Now, I trust my solution because it makes sense. The number 11, whoa. No, guys, I'm so sorry. Go back to 11. You guys may have caught this already. Here's a mistake. Guys, what is -3 plus 8? It's not 11. I'm crazy. But this goes to show I knew my answer was wrong. When I got 11, I knew it was wrong because it's not between -3 and 9. It's actually a good example of that. So now, when I go back, I know this should actually be 5, right? -3 plus 8 should be 5. So 5 should go here. Very cool. And, that's a good way to catch your mistake. So we know that this number makes sense because 5 lies between these numbers and 12 lies between these numbers. So perfect. For the last one, we're going to do midpoint. Now, there's 2 ways to do this. You can either do it like we just did, but you go half the distance because midpoint is the middle. So you can go half the distance doing the same strategy we just did. If you don't want to do that, you will have a formula provided for you on the by the Star Geometry Materials. That little purple sheet we have in class that's eliminated. And it looks like this. So we know that the midpoint of two numbers is x1 plus x2 over 2, comma, and then this is the, let me do it in blue maybe. Here is the x coordinate, and then the y coordinate. I don't have a, oh no. I hope this is red. I hope that's red. I really can't tell. Over here, this will be our y coordinate. We have the other one, y1 plus y2 over 2. And of course, if we wanted to plug that in, we could just do exactly what it says. Let's see, in blue, we have 14 to a negative 4. So, 14 plus a negative 4 over 2, comma. And then in red, we have the y coordinate, same thing, 13 to 7. 13 plus 7 over 2, close parentheses. All right, and of course, negative 14, 14 plus negative 4 is 10, divided by 2 is 5. So this coordinate will be 5, and you can just plug that in the calculator if you wanted to. 13 plus 7 is 20 over 2 is 10. So our midpoint must be 5, 10. I know this answer is reasonable because 5 is halfway from 14 to negative 4, where 10 is halfway from 13 to 7. All right. So with that in mind, that's the first page done. If you feel pretty confident, go back to the first page. Rate yourself on this skill. I would say, of course, I would give myself a 5, obviously. I would give myself a 5 because I'm cool like that. But, if you don't feel comfortable, if you feel like, man, fractional distance, that was a long time ago. We haven't done that in a while, man. That's okay. Give yourself a 4, maybe. Maybe you think it's a 4. Maybe that's something you want to study. Maybe you should only really be concerned, though, as your teacher. You should only really be concerned if you have less than a 3.5. But 3.5 equates to having a 70 in that skill. 3.5 out of 5 is like getting a 70%. So that's a passing grade on that skill. So if you have a 3.5 or higher, you should feel okay, like I have a passing skill. If you have less than that, that's something you should probably study. Okay. So on to 2B for this page. There's a bunch of questions, but don't fret, they don't take that long. These are very short questions, which is why I gave you guys a few on this page. Looking through, remember to try these first on your own before I go through them. It's good practice. So, for the first one, number 1, I want to find the slope of a line passing through this point and this point. So on the test, you'll be given this, but you may want to remember that slope, m, is equal to y2 minus y1 over x2 minus x1. This is just how much you change in y, which I think was red earlier, how much you change in y compared to how much you change in x. How much you change in y over how much you change in x. That's all slope is. It's a rate of change. So, with this formula in mind, we can easily just plug in what we know. So we know that the slope of this line, m, might be equal to, on the top we have the y values. Maybe I'll do that in red, sorry. 3 minus 2, so 3 minus 2, that's on the top, over, and then negative 1 minus 3. So negative 1 minus 3, which is, and 3 minus 2 is 1, over, and then we have 1 minus negative 3, or negative 1 minus 3, which is negative 4. So the slope here is negative 1/4. All right. Remember that it's okay to mix up. It doesn't really matter which one is y2 or y1, as long as, like for example, if you chose this to be x2, y2, and then this to be x1, y1, that doesn't really matter as long as they align. As long as you don't pick like this one to be x1, y2, for example, that would be bad. So in this case, keeping them together like this is fine, however you want to do it. All right. And then down here, number 2, same thing. We want to find the distance. So now, this problem says find the distance from here to here. So there's 2 ways to do that. Now this looks like, there's 2 points in space. There's the actual distance between them that you want to find. And then there's like the x and y directions of each. That is like asking, if you know this length and you know this length, then what's this? So this is a Pythagorean theorem problem. So you could do Pythagorean theorem. You can find the distance of this side, so negative 4 to negative 1. Let me write that down. Negative 4 to negative 1, that's a distance of 3. And you may know on this side, on the red side, on the y side, 2 to negative 2, that would be 4. So you may already know, like this is Pythagorean theorem, and you could do 3 squared plus 4 squared is equal to question mark squared, or x squared. I'll call it c squared to stay true to the formula. This is exactly the distance formula. If you want to do it that way, that's totally fine. I'm just going to write down the distance formula since that's what's provided on the exam. You can totally do it that way if you want to, though. For here, I have the distance d is given by the square root of, and then we have 2 points. We have either order, -4. Here's my, maybe I'll do it in blue, but this is my x direction. Sorry, x1 plus -1, close parentheses all squared, plus, I'm sorry. Yes, excuse me, this should be a minus here. -4 minus -1, my bad, guys. -4 minus -1, all squared, plus, open parenthesis. And then in red, we'll do the y values, 2 minus a -2. As long as you keep those guys aligned, it doesn't really matter which one you pick for which. And then here, the same thing we've been doing. Now, you could put this all in the calculator. If you're going to do this all in the calculator in one step, you need to be a calculator wizard. You need to be an expert. You have to have all your parentheses lined up. Everything has to work out perfectly. In my opinion, it's much easier to do this by hand, so you can see if you have any mistakes, right? -4 minus a -1, that is -4 plus 1. So I'm just going to write on all my steps like this. This is a -4 plus 1 squared plus, and this will help you later with algebra skills too, so it's really beneficial. 2 plus 2 squared equals, and then here I have -4 plus 1, that's 3. 3 squared, and then plus, and then I'll have a 4 squared. Look at that. That's exactly what we wrote for Pythagorean theorem. So if you knew the Pythagorean theorem, you could cheat to the end. You could go straight to the end of this problem. But either way, it doesn't really matter. However you want to do it. I'm going to take this little thing I drew and move it up here so I have some more space. So sorry if you wrote that in pen. But over here, same business. I know that 3 squared is 9. I know that 4 squared is 16 equals the square root of 25. Now, I'm not going to lie. We got lucky right here. We got lucky here. This does happen to be a perfect square, so I do know what the square root of 25 is. If you didn't, just put this part in the calculator. Once you get to the square root of some number, that's a good thing to put in the calculator, right? It's hard to do square roots in your head. Let's just tell the calculator to do it. In this case, we do know that the square root of 25 is technically plus or minus 5, like we learned in algebra class, right? Technically plus or minus 5, but we're in geometry. We know that we're talking about a distance, so it's really just the positive root. Square root of 25 is 5. If you didn't know the square root, just put it in the calculator. No hesitation. All right. On number 3, it says, find the slope of a line that is parallel to the equation. I'm sorry, guys. I think I'm getting sick. I'm super nasally, super sniffly. Parallel to the equation, y equals -3x plus 1. So, first thing, good thing to know, maybe I'll scroll back up to the top. This is like a personal note kind of thing. But good thing to know, lines, if a slope is parallel to another slope, if m1 is parallel to m2, this means that they're the same slope, of course. All right, so this means you have the same change in y as you do same change in x for these guys. Of course, these lines that I've drawn here, well, I'll make it blue instead, and then this one I'll make red. These slopes have to be, these lines will be parallel because their slopes were the same, right? So same thing. If you want parallel lines, we need their slopes to be the same. So I'll come down here, and from this equation, this is in, and this would be on your test too, by the way. You'll have the y equals mx plus b form. Y equals mx plus b. I know that m corresponds to the slope, so this must be the slope, -3. So I just need to pick a new line, like y equals a new line, like, I don't know, anything, as long as it has, for its slope, -3 as well. It has to be the exact same. So for me, y equals -3x, and it just has to be parallel, so I can pick any b I want as long as I don't pick 1, because then it would be the same line, right? So I'm just going to pick 2. 3x plus 2. That's a good example. You can pick anything you want here. You can pick 0. Pick 0, that's another good line. You can even do like a crazy number, like -3x plus pi squared. You know, I mean, if you really wanted to, that's also sufficient, as long as it's shifted, not the exact same line, and they're parallel. So parallel because they have the same slope, right? Parallel because they have the same slope. All right. Same thing for this guy. We're going to do a similar strategy. I want to find the slope of a line that is parallel to the... Oh, wait. Oh, I got to cut that out. Oh, no. So really, if you just want to find the slope. So this problem says, find the slope of a line that is parallel to the equation. Oh, see. This is horrible. No, so sad. Okay, we're going to have to go back and cut that out. For number 3, you want to find the slope of a line that's parallel to the equation y equals negative 3x plus 1. I don't know why this is so spaced out. That should not look like that. But we're looking for y equals negative 3x plus 1. Here's our line. We just want to find a line that's parallel to this one. So if we look at the slopes, we know, and maybe something good to add to your notes, is that if slopes are parallel, this means that they have the same slope, right? Lines with the same slope here, I'll draw one in blue. And then here's my other line that's parallel to this guy. They're only going to be parallel if their slopes are exactly the same. If they change by the same rate, they'll never touch. They must be parallel lines. So these guys, sorry, that's supposed to be red. These guys will have the same slope. Same slope is parallel. Down here, I will make a note of that. I really just need the slope that I pick for my line to be the exact same slope. So I'm just going to copy it over, negative 3. That's all I need for this problem. I just wanted to find the slope that's parallel. Well, that's what I did. Now, for the same thing, for number 4, a similar strategy. I want to find the slope of a line that is perpendicular to the equation. Here. Now, I see this. Whenever I see this immediately, because I've been teaching forever, but if you haven't been teaching forever, you may look at this and be kind of confused. Don't worry. If you see this and you're not sure what the slope is immediately, you can always turn it into y equals mx plus b form. So I'm going to do that really quickly by realizing this is the same as, and maybe I won't write equals, I'll draw a little arrow. But this is the same as y minus 3 equals, now distributing my 3/4 out to both terms. So there's a 3/4 x. Minus, and then 3/4 of 8 is 6. Split 8 into 4 parts, that's 2. 3 times 2 is 6. Same thing here. And then I'm going to move my negative 3 over to 3/4 x minus, and then negative, I'll be adding 3. Sorry, I should say I'll be adding 3, right? So adding 3 to both sides, that gives me minus 3. Now, this is in y equals mx plus b form, so we know the slope is here. Now, you may have known earlier, if you saw that 3/4 was the slope earlier, that's okay. All we really need to know is to make a perpendicular slope. So, up here, another good thing to write is that when slopes are perpendicular to each other, this means that one is the negative reciprocal of the other, that we've talked about. So here, these lines, like this blue line, if I had to change this much and then this much to make the slope for this line, then if I wanted to make a perpendicular line, I would have to take this arrow and flip it upside down, which would make it negative and reciprocated. Oh, I'm sorry, and change places, right? You have to take this arrow, flip it upside down, so you could go down instead, and then change the places of these arrows. So you'd go this length and then this length down, right? That would be the negative slope, which is shown here. Oh, no. Which is shown, okay. Thank you. Which is shown here. Excuse me, sorry. Here in red, right? So same business. These guys will be perpendicular. So all I need to know is that my new slope would be, it would look like 3/4, but it would then be flipped over to 4/3, like any fraction, reciprocated. This is called reciprocated, 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 and then negated. So this is my answer right here, negative 4/3 for the perpendicular slope. So down here, it says, in your own words, what about the slope makes lines parallel or perpendicular to one another? Now, look what this says. This says, in your own words. In your own words. So if I write something here, and you write exactly what I write, you are not understanding the question. You're not doing the right thing, right? Oh, sorry. I really want you to think about this and what this means and write this down for yourself. But I'm going to give you an example of something similar so you can see if you're right in your own answer. It says, what about the slope makes lines parallel or perpendicular to one another? So basically, what's the big deal with slope? What's so important about slope? For me, I would say something like this. I would say slope measures steepness of a line. It's kind of like the measure of the steepness of a line. And I'm putting that in quotes because that's not mathematically correct. Really, the slope is the rate of change, right? But the rate of change comes across in its graphical format as a steepness. So it looks like the slope measures steepness of a line. So since it measures the steepness of a line, it can control parallel and perpendicular because if they're the same steepness, they'd be parallel. So I'm just going to write that. Same steepness, same steep is parallel, and then perfectly opposite steepness would be perpendicular, right? Perfectly opposite steep would be perpendicular. All right, so you can see my answer that I've written. You can see my answer I've written has very weird wording. It's phrased very creatively. If I see something very similar to mine, I'm going to know that you weren't listening to the audio and that you were just writing stuff down. But anyways, define perpendicular for yourself. This is question number 6. So this also says for yourself. Now, for yourself, okay, if you like my answer, it's for you. You can write my own answer here if you want to. Perpendicular for you. I mean like this. This is a big misconception. So we talked in class. I think you guys' last math teacher, there was a little bit of a misconception or idea going on. Perpendicular does not mean intersect. I should say that. Perpendicular lines do intersect. Let me write that over here. Perpendicular lines do intersect, definitely. But they intersect at 90 degrees. But they intersect at exactly 90 degrees. Perfectly. This is what's special about perpendicular lines, not that they intersect. If lines are like this, and they just touch, they're just called intersecting lines. There's no special words. Or you may call them skew. But we haven't talked about that yet. Okay, you may call them skew. That's later. Ignore this for now. This is a perpendicular line. This. These is a good example of a perpendicular line. It's like the complete opposite of parallel. All right, so next page. So for 2C, equations of parallel and perpendicular lines, this is like generating the equation of a line. Some good stuff to know. Now this will be given, let me say this, given on test anyways. So you'll have access to this. But good stuff to know is point slope. The point slope form of the equation of a line. Y minus y1 equals m times x minus x1. Nothing crazy. This is where x1, y1 is just a given point. You would already know these, right? The little subscript of 1 and 1 here are just meaning that they're not variables, right? We're just saying that, like, we know these numbers. They would be given to us in the problem. Like, we would see, like here, for example. This point is given in the problem. This would be a good example of x1, y1. Another good thing to know would be slope-intercept form. You don't have to write all this down if you don't want to, because it'll be given to you on the test. It's just we're walking through it. Good stuff to know. Y equals mx plus b. I'm not a genius. Whenever I come down here and I see these equations, I'm not a genius. I've just seen these equations before. I know what they look like. I know how they behave because we studied them, right? So, for example, number 1, I want to find the equation of a line that passes through the point, this, negative 1, 2, and has a slope parallel to the line y equals 3x plus 2. So this is in mx plus b form. So the m right here, that's the slope, that's 3. Now a parallel slope is also 3. They have the same slope, they're parallel. So I need to make a line. I'm finding the equation of a line. So I need to make a line that has a slope of 3 and passes through this point. Okay. Well, don't I already have a formula or an equation that does that for me. I have a slope. This is literally called point slope form. I have a point and a slope. So I do the same thing. Y minus, and then here's my x1, x2. I'm sorry, my x1, y1. My given point. So y minus y1, that's y minus 2 equals, and then my slope I know has to be 3 so that it's parallel onto x minus x1. All right, and I mean, I could simplify. This is technically done. Like, I'm not going to lie. This is done. This is a good, perfectly mathematically valid answer. All right. I'm going to simplify it just a little bit just to make it easier on my eyes because I've done math for a long time. All right, and I'm just going to make, minus and negative 1 is plus 1. All right, so here's the point slope form of a line that has a slope that's parallel to the given line and must pass through the point, negative 1, 2. Very cool. You're welcome to simplify this to y equals mx plus b form if it makes you feel any better. I'm not going to. It will be y equals 3x plus 5, in case you wanted to know. But it doesn't ask for that. It doesn't ask you to simplify, so you don't have to. All right, for number 2, find the equation of a line perpendicular to this guy. So I just need any line. Any line. It just says a line. It doesn't say a line passing through. It just says a line. So I'm going to make a line. Only thing it has to be is perpendicular. So for perpendicular, that's the negative reciprocal. One more time. So you have to negate and flip. So for this guy, it would be, let's see, there's negative 3/5. I would flip it over and then make it negative, okay? Well, a negative of a negative number is positive. So the positive 5/3 is the slope perpendicular to this slope. So if I make a new line, for example, in the slope-intercept form, if it has a slope of 5/3, it must be perpendicular. Now, it doesn't really matter. And remember, the b here, what I'm trying to say is, like, this b here, it doesn't really matter what b is, because all b tells you is where we intersect at the x-axis. This is just your x-intercept. And maybe I'll write that in blue. Be a little bit cleaner. This is your x-intercept. So it doesn't really matter what you pick for this your y-intercept. I'm crazy, guys. I'm crazy today. This is your y-intercept. Sorry, guys. If you plug in 0 for x, right, this would go away and you would be left with your y-intercept. But anyways. Down here, we can write any number we want. I'm going to put 3. It could be any number, though. You could even pick the same number. In the case of perpendicular, put 2. Whatever you want. I'm going to put 3. I like 3. 3 is a cool number. And I'll box it in. We have found an equation that makes a line. This is an equation. Found an equation that makes a line whose slope has to be perpendicular to this guy's slope. We're done. As long as you do this, this, and this. Right? You've answered the question. All right, so next for number 3, same thing. There are tons of answers to number 2. Tons and tons and tons of different answers for number 2. If you got something different, don't worry. As long as you did an equation, that's a line, that's perpendicular, you're good. So name any line, perpendicular to the one that passes through this and this. So if I want to make a line, I have 2 equations up here I could use to make lines, but it wants it to be perpendicular to the one that they've given me. So if I wanted to know the slope of this line, I'm going to need to know the slope of this line if I want it to be perpendicular. So the slope, I might write m1, is the change in y over the change in x. So of course, in the y direction, we have a 5 and a 1. So if I write my fraction bar, it's going to look like 5 minus 1. That's y2 minus y1. Over, and then in blue, my x direction at the bottom, 4 minus 3, which is equal to 4 over 1, which is 4. All right, now I need a perpendicular slope. So to get my perpendicular slope, I'm going to flip it. Sorry, I don't know why I did that. I'm going to flip it to 1/4 and then make it negative. There's my slope. Now I just need to write the equation of a line that's perpendicular. So I'm going to write y equals negative 1/4 x. Now my b, again, I'm using slope-intercept form here because I know the slope and I don't really care what point it is. So since I don't really care for a point, I'm just going to use slope-intercept form. It doesn't really matter where this guy passes through. I can just pick any b I want. So I'm going to pick 2. You could pick 0. You can write nothing here. You could write this. This is a sufficient explanation because 0 is a good intercept. You could pick 2. That's fine too. I'm going to box it in. I know my answer is okay because it is the equation. Let's see, it is a line. So I made an equation that makes a line. So it's a line that's perpendicular to the one that passes through these guys. Perfect. For the last one, we just want to write the equation of the line that passes through this point and this point. To do this, the easiest way is to first need the slope. If you go over here, if you want to make an equation of a line, you guys see making a line. The two ways I know both need a slope in them, right? So if I don't have slope, I'm busted. I gotta have slope. So I'll come down here and describe the slope first by using my formula. I know the change in y over the change in x, same thing. I have a negative 10 minus, this is my y direction, negative 10 minus a negative 2. Don't forget those parentheses when you're using negatives. Negative 5 minus a negative 1, which boils down to 10 minus a negative 2 is really 10 plus 2. Whoa. Which is, and then, see, I'm getting ahead of myself now, but, and then negative 5 plus 1, that would be 4, oh, see it, sorry. Meant to write 5 plus 1 here. Negative 5 plus 1. And this should be negative 10 plus 1. All right, and then on the top, I have, a negative 8, and on the bottom, I have a negative 4. So negative 8, now this is a fraction that says negative 8 over 4, but we know that negative 8 divided by 4, we can do that. We can already do negative 8 divided by 4, negative 4, that's positive 2. Negative divided by negative is positive. I'm left with positive 2. And here is my slope. Now, I just need to write the equation of a line that then passes through this point. Luckily, since I now have the slope, and I have 2 points I can use, actually I could use either of these points. I have a point I can use. I'm going to use point-slope form because I have a point and a slope. Down here, I'll resume by writing, and I'm just going to pick this point. You can pick either point, it doesn't matter. I'm going to pick the first one, just because it has smaller numbers. I mean, it doesn't really matter, though. I'm going to do minus a negative 2 equals, and then my slope I just knew was 2 times, and then x minus x1, which is a negative 1. Now, you can't change your point halfway through. You have to make sure, like if you pick y1, it comes from the same point as x1. Okay, so here's y1, here's x1 in this case. If you were to go here, this would be x2 and y2, right? So you have to make sure, just basically don't mix up your points. And then anyways, if I simplify, it'll be y plus 2 equals 2 times x plus 1. We've just found, is the equation of a line that passes through the point. All right? So we've made an equation of a line that passes through the point. We're done. That's all we need to do for that problem. All right, on these last 2 pages, this is the stuff we've done most recently in class. So during this week is a lot of when we've seen these kinds of transformations and stuff. And then I guess it was Thursday, Friday, and Wednesday for you guys where we did this. So this has still been some time ago. All right, anyways. So for finding the scale factor, remember the scale factor is this letter K. This letter K, I mean, we call it K. It could be anything in the world. You can use X. You can use S. It could be whatever you want. For these guys, I'm trying to find out the scale factor dilated from this guy to this guy. So if I'm dilating from 15 to 8, I want to know how do I get there? What do I scale by to get there? Now, if I'm scaling by something, that means I'm multiplying. Oh, excuse me, I kind of gave it away there. I want to multiply by something, 15 by something, to get 8, because this is the scaling in the x direction. Now, the x and y directions are scaled the same way. You could do 12 to 6.2, excuse me, I meant to do that in red. You could do 12 to 6.4. That's fine. I'm going to do 15 to 8 because they're whole numbers. I just need a number, so when I multiply it by 15, I get 8. That is what algebra is for. It's for answering questions like this. So I'm going to plug in k here. Could use any letter. I'm just using k because that's what we normally use in geometry. But then I can divide both sides by 15 to get 8 over 15. That's it. That's all you do. K must be 8/15. If you think about that, that makes sense. Because if you multiply 15 times 8 over 15. The 15s would cancel, and you're just left with 8. So this really does, the value of k really does map 15 to 8 in this case. This one is a little more involved. We're doing 3 transformations. We're going to first rotate, then we're going to translate, then we're going to reflect over this line. So, firstly, to rotate something 270 degrees, remember in math, a positive rotation. Maybe this is something to write in the notes. A positive rotation in math is counterclockwise. A negative rotation in math is clockwise. So it's backwards in math. You can thank physics for that. We didn't want it that way. Anyways, 270 degree rotation counterclockwise, isn't that the same as a negative 90 degree rotation? We could just turn the other way by 90, right? We'd be the same way. And remember, the way you remember how to rotate these guys is that if you have axes, one of those steps is 90. So 2 of those steps is 180. 3 of those steps is 270. And all 4 of those is 360. You guys ever heard like a skateboarder, do like a 270 or something? I don't think a 270 actually is a skateboard move, but you get my point, right? If they do a 180, pop shove it or something, that's how it works. Same business, right? If we're moving from this guy to this guy, that'd be 90. Here to here, 90, and then those are just multiples of 90. Okay. But you guys can see if you were going to go 270, that's the same as walking backwards 90. So this is what this notation here is what I mean by that. Anyways, so instead of going all the way around the whole picture this way, I'm just going to go this way. I know that my picture, I don't really know the exact points right now, but I know my picture, since it's in this quadrant, if we're being rotated to the right, or I should say clockwise, 90 degrees, it should end up somewhere in this quadrant. So if you ever are plotting a point, like say if you're picking this point and it ends up over here somewhere, you would be like, oh, wait a second, it has to be in this quadrant. So anyways, here's my first image. I'm going to label it T for triangle, and just so I can have it for clarity. You don't have to do that, of course. All right, this first point here, I'm trying to rotate to the clockwise 90 degrees, so I'm going to break it down into its x and y directions. Maybe I'll keep them blue and red. Blue and red. All right, well, if I rotate the blue arrow 90 degrees, it looks like this. If I rotate the red arrow 90 degrees, it would look like this. So my new point must lie here. There's my new one. So that's just breaking it down into 2 pieces. Same thing for this guy. You guys can see I have the same blue arrow for this next point I'm about to do, this point here. Same blue arrow, but then the red arrow is much taller. Okay, let's see. It is 1, 2, 3, 4, 5 tall. So I need to go, instead from here, 1, 2, 3, 4, 5, all the way to here for the next point. Okay? And for my last point, way over here, let's count the blue. Same business. 1, 2, 3, 4, 5. And then it's actually up by 2. So if I was going to rotate this blue arrow, I'd have to go all the way up to the top. That's 5. 1, 2, 3, 4, 5. And then here this way. 1, 2. My last point would be here. Okay. So I'm going to use the iPad to draw a perfect triangle because I'm cool like that. But this guy would be T prime. So I've moved the triangle over. Here's T prime. Maybe I'll color it blue, kind of like the picture. It needs to be way bigger. There you go. There's my new triangle. That's the rotation to T prime. So now I want to translate to the right. Oh, I'm sorry. This is supposed to say, sorry guys, change this in your notes. I'm going to white it out. This is supposed to say -2, -2. So change that in your notes. -2, -2. Okay, so left 2 and down 2. Remember, this guy is a vector. A vector that shifts the whole plane, and it looks like in the x direction, -2, and in the y direction, -2, which translates to left 2, down 2. So here is the vector. It like starts here, and then it pushes the whole plane down to left 2. So I'm going to move all these points down 2 and then left 2. It's easy as that. So this point, I'm going to move down to left 2 to here. This point goes down to left 2 to here. I didn't add my dots there. And then this point down to left 2 to here. Not that bad. Now I'm going to make my new triangle. Since I already used T prime, we just use T double prime here to notate this guy. And we'll also highlight him blue. All right. So first we did a rotation by 270. I guess really that's like this. Then we translated. All right. For the last thing, we now need to reflect it over the line x equals 2. So the line x equals 2 must pass through x is 2. And I'll do this in this color. I don't know what color this is, but this color. Through x equals 2. Here's the line. X equals 2. It's the vertical line that passes through the value of 2 for x. And I'm going to flip over that line. So this point here, and maybe I'll do my new points here in blue. This is my last picture. Well, maybe not. Maybe I'll do it in like gray real quick. So like this point would move to here, right? And then this point would flip over. It's 1, 2, 3 away, so it needs to be 1, 2, 3 away to here. And then this point is 1, 2 away, so 1, 2 would be here. My last picture would go here. All right. It is a lot to draw in the same picture. That's okay, though. And this final triangle would be T triple prime. Or sometimes we might write like in the parentheses, like if it was a really big number like 12, for example, we might write 12 in parentheses to show it's like the 12th but you know, no big deal. As long as you have the triangle down, don't worry too much about that. That looks good. Make sure like translations, rotations, dilations, and reflections come up a ton, right? A ton. We use them all the time. In real life, they're used in everything, the way your iPad works, you know, all kinds of stuff like that, computer science. Anyways, so for the last page, the final page, this is kind of a little bit of an extension, but really needs to be discussed anyways. This is more of a puzzle problem phrase, and now this is phrased more difficultly, so that it would be, you know, people would be encouraged to cheat in the game we played. But anyways, all I really want to do is find all possible lines of reflection or lines of symmetry, and then find all possible rotations of the given figures. So my lines of symmetry, that's just a line I could have flipped over. So like, for example, if I folded my paper down this line, and I'll do it in like red so it's easier to see. But if I folded my paper down this line, then you guys could see all these pieces would line up like over here. You know, these pieces would line up with each other. So that could have been a possible line of reflection. If in this figure, here's another one. There's another possible line of reflection. Here's another one. There's another possible line of reflection. I don't know why it's like, yeah, fighting me. What? There's another possible line of reflection. So these are lines, so I guess you should draw arrows. And then, like, same thing for this guy. There's another possible line of reflection. I don't know why my iPad's freaking out. Sorry, guys. All right, so there are 1, 2, 3, 4 possible lines of reflection. Now, if you drew other lines, you would risk these, like, if you try, for example, a lot of students want to draw this line, but this line doesn't really make sense, because here, you're saying that this point has to be the same distance from the line as this point is, but obviously that's not true. This one's way farther away, right? If you were to fold your paper down this blue line, you would see it's not a line of symmetry because the paper wouldn't line up. Now, for possible rotations, I mean the same thing. How much can you rotate by? So in blue, I'll do rotations. How much can you rotate by and then still be the same figure? Well, it looks like you could rotate by 90 degrees, and that'd be the same picture. You could also rotate by, 180 degrees. That'd be the same figure. You could also rotate by 270 degrees. That'd be the same figure. You could also rotate by 360. So there's a bunch of possible rotations as well. Now, really any multiple of 90. So maybe if you wanted to say all multiples of 90, but it's okay just to write the 4. Just to write the 4 down. So really there's 4 of each. There's 1, 2, 3, 4 rotations, and 1, 2, 3, 4 reflections. All right, so now that you've been through, there is Delta Math available for this whole section. Go through, Go back to the first page. Look at the work you did. Compare it to the solutions you saw that I did. Go down and write down the skills. I know a lot of people are not very confident on this skill. If you're not very confident, write a low score for yourself, and then don't be surprised on the test if that's what's hard for you, right? This is the stuff you should be studying, is the stuff you write in this column that you rate yourself as a low skill. This is how you study for mathematics. You have to first try, see how good you do, rate yourself on that skill. For example, if you thought you were bad at 2A, write a 3. All right, that is a 60% on that skill. If you want that to be a 70 so you can pass the class, go on Delta Math. It's available. It's free. Okay, and just practice some problems. Then take a break. Don't, like die at the computer doing Delta Math forever. But write some stuff down on paper. Try it. Practice it. Send me an email. I'll be waiting, diligently waiting to answer your questions. So make sure you're on track for the test, which will be on Monday for On Level. All right, you guys have a good